Good morning, all of you. In today's session, we are going to continue with our previous series. In the series 1, we completed CSIR NET GRF Chemical Science June-November 2020 Part C question paper. So we already completed June-November 2020 Part B entire question paper in the single session. So now we entered into where different series have been recorded. So which used to solve 10 questions in each series. So this kind of previous question paper discussion analysis will helpful for your competitive examination and even entrance examinations of various kind. So GATE entrance, CSIR NET GRF examination and even IIT entrance examination, it will be very much helpful to you. So let us enter into our actual concept. This is a kind of system where we are going to discuss 71 to 80 questions of this June question paper 2020 Part C Series 2. So 71 to 80 questions going to be discussed in detail. Let us go with question number 71. In question number 71, they are asking about term symbol of D3 system. So D3 system, the orbital is of 5 degenerated orbitals are present and it's a quantum number is assigned as +2, +1, 0, -1 and -2. So in case of D3 system, 3 odd electrons will be there. After half filling, then only here electrons can be occupied again. So 3 electrons will be occupied in this manner. This is in accordance with Hund's principle, right? So we are assigning here quantum numbers. Total L value take is +2 and +1 +0. Totally, it will become L is equal to 3. L is equal to 3 for atomic turn symbol. L is equal to 0 is denoted for s orbital. 1 is denoted for p orbital. 2 is denoted for d orbital and 3 denotes F. So here L value is 3. That's the reason why here we indicated F as the term symbol here. Now let us find out its spin multiplicity. So how many electrons are there? 3 electrons. For each electron, we have spin quantum number 1/2. For 3 electrons, it will be 3/2. So let us substitute S value in this formula. 2 into 3/2 plus 1. 2 get cancelled. 3 plus 1, it will become 4. Right? Spin multiplicity will be 4 and F will be the term symbol. Let us find out J value here. What is J value? J value is calculated based on number of electrons present in the d orbital. Here, d orbital is there with less than half filled electronic configuration. For less than half filled, the J value is assigned as L minus S. If more than half filled is there, it will be L plus S. Now, L minus S is nothing but, what is L value? 3. What is S value? 3/2. 3 minus 3/2, if we take LCM, then it will become 3/2. So here subscript should be 3/2. 4F 3/2 is the term symbol for this D3 system, right? So this is about question number 71. Let us enter into question number 72. The geometry or shape of Fe4 core cluster of Fe4C CO taken 12 - 2 will be. Here the cluster structure is given where we have iron. 4 iron atoms are there, 1 carbon is there, and 12 carbonyl functional groups are present within the molecule, right? So here, in order to get the cluster structure, first we have to predict total valency electron count present in the given complex. Whenever 4 iron atoms are present, each iron is consisting 8 electrons in its valency shell. 8 into 4 iron atoms are there, it will become 8 into 4. Then how many carbon atoms are there in the complex? Only 1 carbon is there. So that carbon valency will be 4. It is indicated as 4. Plus, how many carbonyl groups are there? 3 plus 3, 6 plus 3, 6 plus 3, 9 plus 3, 12. Total 12 carbonyl groups are present within the molecule. Each carbonyl is able to contribute 2 electrons to the system. So that 12 into 2, it will become 24. And total complex is associated with -2 charge. So that these 2 electrons will be added here. Then total valency electron count for this complex will be 62, right? So this is the complex we can assign. Based on the 62, the cluster structure will be definitely butterfly structure. where 4 iron atoms are present in this manner and carbon is having bond with 4 iron atoms, being it is a tetravalent, being it is tetravalent, 4 bonds it able to form, so that here there is a possibility of 4 bonds with iron atoms, and each iron contains terminal carbonyl groups. How many? 3 terminal carbonyl groups will be there. This is the entire cluster structure of what complex? Fe4CCO taken 12 minus 2, right? The correct answer for 72 will be third one. So third option will be the right answer for question number 72. Let us move on to question number 73. The product of A of the following reaction. Here is the complex was given. This is called a ferrocene. Iron is in contact with 2 cyclopentadienyl anions. This is the kind of organometallic compound. Organometallic compound where iron is surrounded with cyclopentadienyl anions. So what happens? It is treated concentrated sulfuric acid. It is very obvious that we know that sulfuric acid is a proton donor, H plus donor, and here iron complex is able to accept the hydrogen and is turned into FeH total positive. So this will be the right structure in order to treat this ferrocene with concentrated sulfuric acid. Sulfuric acid is a strong acid used to donate H plus, so that there is a formation of FeH whole positive. Whenever we are having nickelocene, in that nickelocene, this is the possibility. Compound 2 will be formed if the central metal is nickel. But in case of iron, the probable distribution, the probable acceptance by iron rather than cyclopentadienyl anion. So the correct structure, the correct answer for this question number 73 will be option number 3. Let us see what will be formed in this. Upon treating ferrocene with concentrated sulfuric acid, there is a direct hydrogen linkage with iron rather than cyclopentadienyl anion. So that option number 3 will be the right answer for this question number 73. Let us move on to question number 74. The number of peaks with relative intensities observed in HNMR spectra of Cp2 iron CO taken twice plus 30 degrees and minus 80 degrees in diethyl ether respectively. Okay, here 2 different conditions, temperature conditions are provided to us, and proton NMR spectra of this compound was given. So based on the temperature, we can predict the set of proton NMR signals in the compound. That is purely based on the concept of fluxional and non-fluxional nature of hydrogens. Fluxional nature in the sense, if hydrogens are interconvertible and being all are identical, that's said to be a fluxional nature. Non-fluxional in the sense, whenever temperature is lower, shipping of hydrogens may not be possible and they are rigid state. In that case, we can't find the interconvertible hydrogens. In that state, all the hydrogens are not having equal or identical nature. So that is called non-fluxional. That is possible at lower temperature. Then let us predict what is the effect of temperature in HNMR spectrum of Cp2 iron CO taken twice. For that purpose, we are taking this compound where iron is associated with 2 cyclopentadienyl anions and more 2 carbonyl groups are present around the central iron. Right. So in this complex, first let us apply minus 80 degrees low temperature condition we are going to apply here. Whenever low temperature conditions applied, one of the ring remains as such, all the protons are in the fluxional nature and these are said to be a one set. But second cyclopentadienyl anion ring is associated with, this is of hydrogen which is directly linked to the carbon which attached to the metal. So this is one hydrogen and these 2 hydrogens are said to be one type. HA hydrogens are said to be one type and these 2 HB hydrogens are said to be one type. Total how many set of hydrogens in this complex? 1, 2, these 2 are 2 only. Then this is of any other kind. So total 3 set of hydrogens are available on this cyclopentadienyl anion, and entire this cyclopentadienyl anion is said to be one kind only. Total possible equivalent hydrogens are 4. 4 hydrogens are there, hence it able to give 4 signals within the molecule. 4 signals will be given. Let us see how 4 signals. All the 5 hydrogens, so that intensity will be 5 here. Intensity will be 5 here. Later, these 2 hydrogens are identical, so peak intensity will be 2. So 5 is to 2 and more. HB2 identical protons are present within the molecule. So here again intensity will be 2 and more one hydrogen is there, that is again different. So that we can assign 1. The intensity ratio at this low temperature minus 80 degrees, being it is the rigid molecule, flexibility is missing, means flexibility is missing. So that the possible peaks are 4 and 5 is to 2 is to 2 is to 1 is the peak intensity ratio. Let us apply this 30 degrees centigrade within the molecule. Upon applying 30 degrees centigrade within the molecule, all the hydrogens, temperature conditions, all the protons are interconvertible, interchangeable. Because of that reason, all the protons are in the nature of shifting, delocalization, and all are said to be identical protons, identical hydrogens. And this cyclopentadienyl anion, all hydrogens are of one set, and this set of cyclopentadienyl anion protons are second set. Total how many type of equivalent hydrogens are there in the molecule? At this 30 degrees we have 2 signals because of two type of hydrogens in the molecule. Okay, because all the hydrogens are said to be fluxional in nature. In case of low temperature, there is a possibility of non-fluxional nature. That is nothing but rigid nature will be there. Okay, so at 30 degrees, we can obtain 2 signals for this compound. And the 2 signals are having equal identical setup, one set. Hence, intensity ratio will be 1:1. That's the reason why. So for this CP2FeCO taken twice, at 30 degrees, you will get 2 peaks of intensity ratio 1:1. At minus 80 degrees, the peak intensity ratio will be 5:2:2:1 with 4 peaks. For question number 74, option number 1 will be the right answer. Let us move on to question number 75. In the question number 75, again it is a part of spectroscopic analytical method, where 3 different strong bands are observed in the IR spectroscopy: 1986, 1935, 1601 centimeter inverse. Everybody are familiar with IR spectroscopy, that IR spectroscopy is the fingerprint for functional group identification, right? So all these peaks corresponds to carbonyl groups only. It is very clear that 1986, 1935, 1601. These 3 signals are assigned for carbonyl group only, but based on its surrounding environment, these carbonyl group position or structure will be different. So we have to elucidate what will be the compound here. The starting material provided here will be iridium square planar complex. It is a kind of iridium square planar complex. This iridium is associated with one bidentate ligand, that is PPH2, CH2, CH2, PPH2. This is the chelating ligand. And another side carbonyl group is there, and one more side we have phenyl group. This is called phenyl group. And we are adding carbonyl functional group under gaseous conditions. Carbonyl group will be added to this compound under gaseous conditions. What will happen? Carbonyl group will be inserted in between. Benzene having tendency to insert. Always alkyl group, when directly attached to the benzene ring, there is a possibility of migratory insertion, right? So that's the reason why carbonyl group will be inserted in between phenyl and iridium, so that we will get benzyl. So that benzyl is observed only in option number 2 and option number 4. Even option number 3 is having benzyl. Option number 1 is not having benzyl group. So option 1 can be discarded, and there is a probability of second, third, and fourth. And 1986 is the characteristic peak of benzyl. So it will confirm there is a benzyl group, so that either option number 2, 3, or 4 may be possible for this one. Okay, so this is one of the possibility. Then number of IR stretching bands indicate number of set of carbonyl groups present in the compound. How many bands are there? 1986, 1935, 16, not 1. So there is a possibility of 3 carbonyl groups within the molecule. How many compounds have 3 carbonyl groups? Here we have 3, but benzyl is missing. So option 1 is wrong again, wrong already. So in option 2, we have C double bond O, CO, CO. So 3 carbonyl groups are there, so that there is a possibility of we can suspect this one. And the third compound where C double bond O, CO, CO, carbonyl groups are there, 4 are there, but only the signals are given for 3. So we can discard clearly this option number 3. Only the probability will be option number 2 or option number 4, because both are associated with 3 carbonyl groups. 3 carbonyl groups are there within the molecule, right? So here we have transposition of carbonyl, and here we have cis position of carbonyl groups in the molecule. So here 1985 and 1601 peaks corresponds to this cis carbonyl groups only. That is, it's very clear that compound 4 is the characteristic product which is obtained by treating this starting material of iridium square planar complex. So option number 4 will be the right answer from this starting material of square planar iridium complex, right? So only the thing first we have to predict is 3 signals corresponds to 3 carbonyl groups, and 1986 is the characteristic peak for benzoyl group. So always when phenyl is there and treating with carbonyl, there is a migratory insertion of carbonyl is possible. So even we have methyl group, that also there is a able to form CH3CO group. Acetyl will be formed. Here phenyl is there, that's why we are forming benzoyl group here. So here benzoyl will be formed, and the remaining 2 carbonyls should be in the cis position. Then only these corresponding peaks will be relevant to this product formed. So for this question, option number 4 will be the right answer. Let us move on to question number 76. The number of expected electronic transitions, chromium En taken thrice whole tripositive and trans chromium En taken twice F2 plus at 4 Kelvin is respectively. Initially given, which is a chromium octahedral complex having chromium En taken thrice. It is a chelating ligand, bidentate ligand, hence there is a formation of 6 bonds in the octahedral. What we are doing, one of the ethylene diamine can be replaced with 2 fluorine, because fluorine is monodentate, ethylene diamine is the bidentate. So that in order to remove one En, 2 fluorines are required here. Then number of expected electronic transitions, UV visible spectroscopy, again it is a part of spectral analysis method only. How many peaks are given for first compound and second compound we have to predict. So when we are taking ethylene diamine around this chromium plus 3, ethylene diamine around this chromium plus 3, here it is in octahedral shape, and always it used to give 3 electronic transitions. This is given in the textbook of Concepts of Inorganic Chemistry by Asim K. Das textbook. So 3 chelating ligands are responsible to give 3 electronic transitions within the spectral lines, and here is the how many spectral lines which appeared for this chromium En taken 3. So it is very clear that 3 signals will be appeared for this compound. So these 3 signals at 21,850, 28,700, 46,500, these are the possible regions for this chromium En taken thrice tripositive, right? So here is the compound number 1. Let us move on to compound number 2. Whenever this chromium En taken twice F2 molecule was taken, so it is turned into tetragonal geometry. Initially octahedral is there. Because of electron-electron repulsions, there is a distortion in the geometry is possible. D4 geometry is applicable for this molecule, and the possible peaks, this is the structural representation of the molecule, and the possible peaks are represented within this structure, where you can find 1, 2, 3, 4, 5, 6 spectral lines for this molecule. Octahedral now started into tetragonal geometry. So 4B1G, 4 EG, 4B to G, 4EG, 4A to G, 4A to G. These are the different levels of energies which are provided for this molecule, and any kind of transitions are possible. So it is very clear that transitions are given for the second compound, and this was given in the textbook James Huey for inorganic chemistry, right? So for question number 76, 3 and 6 picks are the relevant answer. Option number 4 will be the correct answer for this one. Question number 77. The value of magnetic moment will be independent of temperature for ACAC, acetyl acetonato, OAC, acetate, orthophenanthroline, and pyrazolyle. So these many ligands are given. We have to predict the magnetic moment, independent magnetic moment. Which compound is having independent magnetic moment, that should be predicted. Here we have iron, copper, iron complexes. Okay. These many complexes are given to us. Let us see where temperature dependent, temperature independent systems are present. I am considering the first compound, Fe, acetyl acetonato. How many are there? Tris acetyl acetonato functional groups are present in this octahedral complex. It is a kind of D5 system. Iron is associated with 5 electrons within the cluster, and in this molecule, iron exists in the form of +3 oxidation state. Tris is acetyl acetonato, iron +3 state, right? So when this compound was taken here, in order to predict a magnetic moment of any compound, we have 3 formulas for the prediction of magnetic moment. One is spin-only magnetic moment. Second is spin-orbit coupling magnetic moment. Third is about mu effective. This is applicable to the huge molecules with the distorted one, right? It is the exceptional one, right? Spin-orbit coupling, spin-only magnetic moment, spin-orbit coupling magnetic moment, mu effective magnetic moment. These many magnetic moment predictions are possible for given molecule. So when we are taking D1, D2, D3, D4 system, mu spin-only value is always greater than mu spin-orbit coupling value. Mu spin-only value is greater than mu spin-orbit coupling value. For this D6, D7, D8, D9 systems, it is a reciprocal. Means we have to invert this entire system. What it will become? Mu spin plus orbit coupling is raised to mu spin-only formula, right? So in both the cases, these are the probabilities. Both are said to be temperature dependent. Only the missing term is D5. That D5 system is temperature independent. So even by varying the temperature, this D5 system will not be varied. In case of this one, spin orbit coupling is also not employed, right? So mu effective formula can be applied for that one. So in that case, D5 system is provided for this tris acetyl acetonato iron +3 complex. That's the reason why for the question number 77, option number 1 will be the right answer. Let us move on to question number 78, 77 just to be completed. Let us discuss about 78. Choose the correct statement for group 15 halides. Osmium trichloride can form complexes type of osmium tetrachloride minus in the presence of chloride source. Whenever osmium trichloride was taken and added with one of the chlorine, Cl minus when added, what happens? It is the chloride accepting ligand. Lewis acid nature will be there. Chloride will be clearly accepted by this one. And there is a formation of osmium Cl4 minus. So it is a correct statement only, right? When we are taking PF3, phosphorus trifluoride, it is a strong sigma donor ligand towards the d orbital. When we observe this phosphorus, pentavalent in nature. So, but in around this phosphorus, we have 3 electron withdrawing ligands. Strong electron withdrawing ligands are there. Hence, there is a possibility of pi deficiency. Electron deficiency will be generated rather than electron donation. Hence, we can say it is a pi acceptor instead of sigma donor ligand. So, it is not the correct statement for this group 15 halides. And the third one, the solid state strontium pentafluoride has a trigonal bipyramidal structure. No, strontium pentafluoride is indicated here. So under solid state conditions, solid state in the sense low temperature conditions, strontium pentafluoride exists in this dimeric or polymeric form. That is a solid state compound. Whenever it exists in either liquid or gaseous form, then only possibility of trigonal bipyramidal. But in case of solid state, the possibility will be polymeric system. So this is also not a right statement. And the reaction of strontium pentafluoride with anhydrous HF generates H2F positive ions. We are taking strontium pentafluoride. That strontium pentafluoride treated with HF, what happens? There is a formation of strontium hexafluoride. This is called a superacid. So antimonic acid, fluoroantimonic acid will be generated. Along with fluoroantimonic acid, one more byproduct will be there, that is called H2F positive. Strontium pentafluoride upon treating with 2HF. So fluorinated, this is called fluoroantimonic acid. It is the superacid. Among all the known acid, it will be the stronger one, right? H2F will be the byproduct formed. That's the reason why the statement 4 is also right answer. This question number 78, option 1 and option 4 both are satisfying. That's why these two are present in only option number 1. So 78, option 1 will be the right answer. Let us move on to question number 79. In the catalytic cycle of cytochrome P450, generation of porphyrin Fe plus 4 oxygen from porphyrin Fe plus 3 OOH involves. OOH involves. We are taking starting material Fe plus 3 OOH. After the reaction, it is turned into Fe plus 4 oxygen. During this reaction, what happens? Iron plus 3 turned into plus 4. Iron plus 3 to plus 4, what happens? Iron plus 3 to plus 4 state is nothing but loss of electron is possible. The cytochrome is turning into oxidation process. So cytochrome P450 is the biomolecule which is very essential for what we can say oxidation. When alkanes are there, they turned into hydroxy compounds in the presence of cytochrome P450. Here is the structure of cytochrome P450 where we have iron surrounded with 4 porphyrin rings and cysteine. Amino acid moiety will be there and terminal polar carboxylic acid and vinyl functional groups also associated within the molecule. This is the structure of cytochrome P450. And during this reaction, what happens? Conversion of Fe plus 3 into Fe plus 4 involves heterolytic cleavage of oxygen-oxygen. Peroxy bond cleavage is possible. So that peroxy bond cleavage is possible. Option number 4 will be the right answer for question number 79, right? So 79, option number 4 will be the right answer. Let us move on to question number 80. And the question number 80, in the following sequence of reactions, correct P, Q, R respectively, right? So compound P was given, which is dissolved in the acetic acid and treated with solid thiourea. Nitrogen and one of the solution is liberated. Now it is treated with ferric chloride, dilute ferric chloride solution, so that the compound obtained here turned into Q, which is blood red in color. Now this compound Q is treated with mercury chloride, HgCl2, right? So this amalgam compound was treated with Q so that colorless compound is generated finally. We have to predict what is starting material P, what is the intermediate compound Q, what is the final product R in this sequence. For this purpose, first we have to take nitrite. So KNO2 is the starting material, potassium nitrate. Potassium nitrate upon treating with acetic acid, potassium nitrate dissolved in acetic acid, now it is treated with thiourea. Upon treating with thiourea, the product will be thiocyanate, potassium thiocyanate formed. Along with this, nitrogen gas is evolved. Here the solution is thiocyanate solution will be generated here. So that is not required to assign because no number is given for this one, right? Solution is treated with ferrichloride. So when this case NS solution is treated with the ferrichloride, the product will be FeH2O taken for ACCN positive. Further, it turned into FeACCN. Okay. So tris thiocyanato iron compound will be formed. Now it is treated with dilute mercury chloride. The final reagent will be dilute mercury chloride, and there is a formation of kind of coordination isomerism. What we can say here, iron initially present in the metal. So mercury complex will be generated here. HgACCN taken for -2 will be formed. Now let us see what are the colors of the compound Q. Compound Q is FeACCN taken thrice will be red color. Then final R product will be colorless in nature. Colorless in nature. That is I. So all these are satisfied in the option number 2. Option number 2 is for this question. K what is the starting material? Upon treating with thiourea, it turned into nitrogen, and one more product will be KNS minus. So it is treated with FeCl3. Formation of FeH2O taken by ACCN positive is generated. Further turned into FeACCN taken thrice will be formed. Later it is treated with HgCl2 so that the final product will be HgACCN taken for -2. So for question number 80, option number 2 will be the right answer. By this, we completed entire 10 questions of series 2. So very much helpful to you. Thank you very much for your patient listening. Thank you one and all.